So I want to start with a prompt. It seems really simple on the surface, but it actually breaks most of the traditional AI models we're used to.
Okay, I'm with you.
It's this idea that team at Assembly AI calls the detective's dilemma. You're a detective, you go to an AI, and you say, paint a picture of a man who would commit such a crime.
And it just stops you in your tracks, doesn't it? Because as a human, you immediately parse the context.
Right.
Is the detective asking for, a psychological profile, a metaphorical picture made of text?
For a literal sketch, like a face.
Or a literal sketch of a suspect's face.
Yeah.
Exactly. And for the longest time, AI just couldn't bridge that gap.
Exactly. I mean, for the last decade, AI has been so strictly divided. You
Ugh.
had text models over here giving you the profile, and then your image models over there generating a face.
And they lived in completely different universes. They didn't speak the same language.
Not at all.
And that is the wall we're finally breaking down. We're moving away from that unimodal isolation into what we call multimodal AI.
Mhm.
But honestly, even that term is getting a little buzzy. What we're really talking about is giving the machine perception, the ability to see, hear, and process reality.
And then this is the key part, giving it the agency to actually act on that information.
That's the whole game. We're moving from passive intelligence, just answering questions, to active intelligence.
And we have a lot to get through today. I mean, we've got some really fascinating architectural breakdowns of how these models are built, looking at everything from the vector math to these new agentic frameworks like LangGraph.
Mm-hmm.
But let's stick with that perception piece for just a minute.
Sure.
Because most people have probably played with ChatGPT or Gemini. You upload a photo, you ask a question. But there was this Munich beer garden demo that really highlighted the nuance here. It wasn't just object detection.
No, and that is the key distinction. Object detection is, frankly, old news. We've had bounding boxes around cars and cats for years.
Right.
In that demo, the user uploaded a photo of a really busy beer garden and asked, is this a good spot for a confidential business meeting?
And the AI didn't just list what it saw. It didn't say, I see tables and beer. It said no.
It said no. It reasoned that the environment was lively and noisy. It even pointed out the lack of privacy because of the communal seating.
It derives social meaning from pixels.
That's a massive leap. It even identified the specific glassware, those large, clear mugs, as a context clue for the whole relaxed vibe.
So it's a multi-step reasoning process. It identifies objects, then it assesses their relationships, then it infers an atmosphere.
And applies all of that to a specific user constraint, which was the business meeting.
Okay, so let's get under the hood a bit, because this is obviously way beyond just matching keywords to image tags. This has to rely on vector embeddings, right?
Heavily. You have to somehow map the visual data and the text data into the same mathematical space.
Which sounds really hard.
It is, because you're dealing with completely different data pipelines. On one side, you've got an encoder processing pixels, just thousands and thousands of numbers for color and light.
And on the other, an encoder that's processing semantic meaning from words.
And you have to force them to align.
Wow.
Well, we use a technique called contrastive learning. Think of models like CLIP. You're not just showing it a dog and saying, this is a dog.
Okay.
You show it millions of these image text pairs, and you're basically a relentless drill sergeant. You force the vector for the image of the dog and the vector for the word dog to point in the exact same direction.
You're maximizing the cosine similarity.
Precisely. You pull the matching pairs closer together, and just as importantly, you violently push the mismatched pairs apart. You make sure that dog image vector is as far away as possible from, say, the taco text vector.
There's that amazing example from Neural Breakdown that just made this click for me. The vector arithmetic.
Oh, the algebra of concepts. I love this part.
They took the vector for an image of an airplane, subtracted the text vector for the word plane, and then added the text vector for the word bird.
And the result wasn't just digital noise or some garbled mess.
It was an image of a bird.
Yeah. Which implies the model isn't just memorizing labels, it's actually understanding the components of a concept.
It gets that if you remove the mechanical flying thing part and replace it with the biological flying thing part, the image has to change in a predictable way.
It proves that the shared embedding space isn't just a big storage locker, it's a semantic map of reality. But, and this is important, we have to be careful. There's a bit of a fake it till you make it dynamic in some tools out there.
You're talking about the pipeline issue, the 3 kids in a trench coat problem.
Right, exactly. When you use a tool and you speak to it and it draws a picture, you have to ask, is it one brain or is it a pipeline?
And a lot of the time, It's a pipeline.
A lot of the time. You speak, a model like Whisper transcribes your audio to text. That text goes to an LLM. The LLM then writes a prompt for an image generator like Daily.
So there's no real reasoning happening across the different modalities. The vision part never actually knows what the audio part heard.
Exactly, and information gets lost at every single handoff. Now compare that to what we call native multimodal models like GPT-4o or Gemini 1.5.
Okay.
These are trained from the ground up on a soup of text, images, and audio all at once. It's one single neural network.
So can hear the sarcasm in my voice.
And correlate it with the smirk it sees in the video frame, all in the same inference pass. It's truly integrated.
Which brings us to video. Because video is just a sequence of images, really, but it adds that whole dimension of time.
And causal relationships. There was another demo with a GitLab compliance video. The user just dropped in a link to a meeting recording and asked the AI to come up with a title.
And it came up with Mastering Compliance Grouping.
A little dry, but accurate.
But think about what that actually takes. It has to track the conversation over time, read the text that's on the shared screen in the video, and then synthesize the entire point of the meeting.
That's temporal reasoning. It's a huge step up.
And then you have projects like Meta's ImageBind, which just takes this to the absolute extreme. They're not just binding text and image. It's, what, 6 different modalities?
You've got text, image, video, audio, depth so, 3D thermal, like heat maps, and IMU, which is movement data from sensors.
The thermal one is wild. So you could, in theory, train it that the sound of a train braking correlates with a very specific heat signature on the wheels.
Yes. Or you could feed it an audio clip of a jungle and have it retrieve an image of a tiger. It's creating this unified embedding space for almost any sensory input.
Feels a lot closer to how a biological brain works. We don't process sound and sight in separate boxes. We integrate them into one single experience of reality.
It's getting there. And speaking of brains, there was that fMRI study.
Right, I saw that reference. It was a bridge between the two worlds.
It really was. They used a multimodal AI to analyze fMRI scans, so blood flow in the brain, and paired that with the audio people were actually listening to.
And the AI could decode the brain activity.
It could decode the brain activity and predict what the person was thinking with surprising accuracy.
So it's basically treating brain activity as just another modality to be tokenized and translated.
Which is both fascinating and maybe a little terrifying. But it shows the power of this universal translator approach to data.
Okay, so we've established the machine can perceive the world with some real nuance. It can map all these different senses together, but perception without action is just observation.
Right.
And this is where we have to talk about agentic AI.
And we need to be really specific with our definitions here because the word agent is getting thrown around as much as AI is these days.
Good point. Let's walk through the hierarchy.
Yeah.
Level 1 is just standard generative AI.
That's the oracle. You ask a question, it gives you an answer. It produces information, but it doesn't actually change the state of the world.
Then you have level 2, the AI agent.
This is where you give the oracle a tool. You give it an API. So if the LLM realizes it doesn't know something, like the current stock price, it has permission to execute a function to go get it.
But the real shift, the thing we're really here to talk about, is level 3, agentic workflows.
This is autonomy. This is where the AI isn't just using a single tool, it's planning a whole multi-step execution strategy to solve a vague, complex problem.
The classic example is always travel booking, but let's use the harder version, the New Delhi in May scenario.
Right, so the prompt isn't book flight BA123. The prompt is, I need to go to New Delhi in May for a week, but only when the weather is bearable. Keep the whole trip under $1,600, and check if I can even legally go.
A standard agent would just fail. It would search flights to Delhi in May and get stuck.
And fail. But an agentic system, probably built on a framework like LangGraph, it creates a plan, a flowchart.
Step 1.
Step 1. Call the weather API. Find the specific dates in May where the temperature is actually acceptable. Step 2. Use only those dates to query the flight API with the price constraint.
But it's that third step that really defines agentic for me, the immigration agent.
This is the critical piece. The system spins up a sub-agent. That agent gets access to your personal files, finds your passport, uses OCR to read the expiry date.
And then cross-references that with current Indian visa regulations.
Exactly. And if your passport expires in, say, 3 months...
It halts the flight booking. It stops.
It halts the entire process and alerts you. It effectively says, I didn't book the flight because you wouldn't be allowed on the plane anyway. That is true agency. It's making a decision to not act based on synthesized information.
That's such a huge leap from just, here's a list of flights. It's managing the outcome, not just the task.
Exactly. And we're seeing this move into the enterprise world really, really fast. Think about employee onboarding.
Oh, for sure.
You don't want a human HR manager clicking buttons in 5 different apps. You want an agentic workflow. You just say, onboard John Doe.
And the agent creates the email, provisions the Slack account, adds them to payroll, schedules the meetings.
Right. And these systems are being built with tools like N8N and LangChain. They're basically the plumbing for these agents. They let developers define the nodes, the steps, and the edges, the logic connecting them.
So we've got the brain, which is the multimodal LLM, and we got the logic, which is the agentic workflows. The final frontier has to be the body, embodied AI.
Taking the agent out of the server and putting it into a robot. Google's Pommy is probably the biggest name here. They call it embodied language modeling.
But this isn't just standard computer vision guiding a robot arm, is it?
No, and that's the key difference. Traditional robotics is very hard-coded. Move arm to coordinates XYZ. Pommy is end-to-end. You tell the robot, pick up the red apple.
And the single model has to process the visual input, understand the semantic command, and then output the actual motor control policies.
All in one go. It's translating language and vision directly into torque and movement. But this brings up a massive technical hurdle, one I really want to dig into. Catastrophic forgetting.
The name is dramatic, but the problem is very real.
It's a fundamental issue in neural networks. I mean, imagine you have a brilliant LLM. It's read all of Wikipedia. It knows poetry, history, how to code.
Okay.
Now you want to teach it to control a robot arm. So you start feeding it massive amounts of visual and motor data.
And in the process of learning how to move the arm, it just overwrites the neurons that knew who Napoleon was.
Exactly. It optimizes for the new task and it cannibalizes the old knowledge. It becomes a great robot, but, well, a lobotomized genius.
So how did they solve this? Because the Flamingo paper architecture seems to be the standard now.
They used a frozen brain approach, which is a great name. They took the massive pre-trained LLM and they literally froze the weights. They said, you are not allowed to change a single number in this core part of the network.
So the core intelligence is locked in, it's safe.
Right. Then they inserted these smaller trainable adapter layers in between the layers of that frozen model. And you can think of these adapters as little translators.
Okay.
They take the new data, the camera feed from the robot, and they translate it into the language that the frozen LLM already understands.
So the LLM thinks it's just processing more text, but what it's actually processing is a translation of the visual world.
Precisely. This lets the model keep all of that incredible world knowledge reasoning, language, logic, while still learning a completely new modality through the adapters.
It's like giving a brilliant professor a pair of high-tech glasses that translate the world for them, instead of trying to do brain surgery to rewire their visual cortex.
That's a perfect analogy, and it's really the only economic way to scale this without having to retrain a trillion parameter model every time we want to add a new sense.
It makes sense. Now, we're painting a pretty rosy picture here of these super smart, sensing, acting robots. But let's ground this. What breaks? Where does this go wrong?
A lot breaks. The black box problem is still the biggest issue. When you have a multimodal system, debugging becomes a complete nightmare.
Because you don't know which sense, which modality triggered the final decision.
Right. Did the agent reject that business meeting location because it saw the beer mugs? Or because it heard the background noise in an audio snippet?
Sure.
Or did it misread a sign on the wall? We call it the meaning mystery.
And sarcasm is a huge failure point.
A classic one. If I say, oh, great job, with a really heavy, sarcastic tone, a text model just sees the words great job.
But a multimodal model should hear the tone.
It should. But if it misses that nuance and the agent goes ahead and sends a thank you email to a client who is actually complaining, you've got a real problem.
And the other one is data scarcity, which sounds, we're drowning in data.
We have quantity, not quality. We need paired data. We need millions of examples of images that are perfectly described by text. We have that for dog and cat. We don't have it for identifying a microscopic fracture in a turbine blade based on a thermal image.
So all the niche industries are going to have to build their own data sets from scratch.
They will, and it's going to be expensive.
But despite all these hurdles, the market is just exploding. I saw a projection that the multimodal market is jumping from something like 1.4 billion to 15 billion by 2030.
It's being driven by pure utility. It's customer support agents who can see your screen while they're hearing your voice. It's medical diagnostics combining x-rays, patient history, and transcribed voice notes all at once. The value of synthesizing information is just too high to ignore.
So if we zoom out, what we're really looking at is a future where the interface itself just disappears.
That's the end goal. The whole distinction between an input device and output device starts to blur. You just treat the computer like a collaborator, you show it things, you speak to it, it does things for you.
The show and tell dynamic becomes the new operating system.
I like that.
But I do want to leave our listeners with a final thought on that doing part. On the agency.
Go on.
We're talking about giving these systems the keys to the castle. Booking flights is one thing, but what about accessing bank accounts, managing official immigration documents, modifying live code bases?
It creates a whole new category of liability.
Right. If an agentic AI executes a workflow that violates a legal regulation or deletes the wrong database or just books a non-refundable flight to the wrong city because it misunderstood a weather report, who's responsible?
Is it the user who wrote the vague prompt? Is it the developer who built the LangGraph flow?
Or is it the frozen brain that just happened to hallucinate at the wrong moment?
That is the question we are all going to be wrestling with for the next decade. How much autonomy can we actually afford to give the machine?
It turns out giving AI eyes and ears was the easy part.
Giving it hands and the judgment to use them properly, that's the real challenge.
We'd love to hear your take on that. And hey, if you want to test the limits yourself, try a multimodal workflow this week. Don't just chat with an AI. Upload a photo of your pantry and ask it for a recipe. See if it can reason about what you actually have.
It's the best way to see the future, or at least to see what's for dinner.
Thanks for diving deep with us. We'll see you in the next one.